Okay, now what we're gonna do is we're still gonna create a buffer using a weak acid, but we don't have any conjugate base salt. So what we have to do is use a strong base to make some. So from the previous videos, what we've done is if we were to plug stuff in, we'd only have an initial value for HA without any A-. I don't have any on the shelf, I can't find it. So what we're gonna do is we're actually gonna use some strong base to take some of what would be this initial HA and can actually convert it before we get to do the equilibrium, convert it to some A-. So again, usually we have about twice as much of the weak acid here that we need, and we're gonna then convert that into the A- by using that strong base, which is usually a hydroxide, right? Sodium hydroxide or potassium hydroxide. That hydroxide is going to come in and rip off that H plus, and create some A-. And those values are then what you're going to plug into your initial values. You need both the HA and the A-. Don't try plugging anything into these initial values until you've figured out what both the HA and the A- concentrations would be. So the first way, just like the other ways we've been doing, they could give you a solution and then give you a solid, right? So they'll give you a solution of the weak acid, and then they might give you a solid strong base. Okay, so they give you a solution of the weak acid, and then they're going to take some sodium hydroxide in this case and strip off some of those H pluses from that HF to create some F minus. So what we need to do is we need to figure out how much HF do we even have, and then strip off the H plus. So we can only really do this very well in moles. So we have to figure out how many moles we have of the HF. We don't have any F minus. We only have HF right now. So let's figure out how much we have. We have 75 milliliters, so 0.075 liters of HF. Of how much HF? 0.20 moles per 1 liter, which means I have 0.015 moles of HF. Okay, well, it'd be great if I could figure out how much F minus I would have, but we're going to actually create F minus from this 0.015 moles of HF. We're going to convert some of this. What are we going to do to convert it? We're going to react it with the sodium hydroxide. So what we need to figure out now is how much sodium hydroxide did we put in there to convert that? So we had 0.25 grams. So if we have 0.25 grams of sodium hydroxide, since this is a solid, we're using mole, the formula weight. So molar mass of that is 40 grams per mole. So 1 mole of sodium hydroxide is 40 grams. And so that tells me right now that we have 0.00625 moles of sodium hydroxide. Okay, why is that important? Well, this 0.00625 moles of sodium hydroxide is what's going to strip off this hydroxide right here, is going to strip off that H plus. How much? 0.00625 moles of it. This is what's being used to convert the HF into, some of it, into F minus. So how much? Well, we have 0.015 moles of HF to start. And we're going to actually change, we're going to swap out, we're going to convert that to, right, the sodium hydroxide is going to react with that. And so we're left with 0.00875 moles of HF. That's how many moles of HF we have. How many moles now of F minus? Remember, that we didn't just lose the HF was converted into F minus. And so what did it get converted into, how much did it get converted? Well, the 0.00625. So you have 0.00625 moles of F minus. Well, we can't plug that into our ice table. We want molarity in our ice table. I have moles, I don't have molarity. How do I get molarity from moles? I mixed, when these are mixed together, I've got 75 milliliters and 0.25 grams. The 0.25 grams isn't going to do anything to volume. There's no volume here, really, and that's negligible. Usually they'll say, and they'll even say the mass is negligible many times. So this little tiny mass is not really going to affect the volume. So what's the total volume here? 75 milliliters. So I have to divide both of those by 0.0750 liters. Okay. And then what does that give me for my final molarity? Well, that's going to give me 0.12 molar HF. And it's going to give me 0.083 molar F minus. Right, this was the F minus. That's the HF. So now these you can plug into your ice table. This might look complicated, but the concept all stems from I don't have any conjugate base available to me in the form of a salt, so I don't want to use that method, so I'm just going to convert some of it using the strong base. The strong base, this sodium hydroxide, never makes it into an equilibrium. You're just using it to convert some of this HF into F minus. Okay. So we did that, we're not sure, we had to convert it, so put everything into moles. Okay, we had 0.015 moles of HF. We added in 0.00625 moles of sodium hydroxide. That sodium hydroxide strips some of that H plus off. How much? Well, 0.00625 moles of it. Okay, so the original 0.0015, we lost 0.00625 to create F minus. Okay, so we're left with 0.00875 moles of HF. And we created 0.00625 moles of F minus. That's moles. We can't use that in our ice table right now. So divide that by your total volume, your mixed volume, which is 75 milliliters. And then you end up with then 0.12 molar HF. And then see how you had started with 0.2 molar? Well, you lost some. So 0.12 molar. And now you've made 0.083 molar F minus. Those are the two values you plug into your ice table, and your hydronium ion concentration starts off as 0. Okay. The second variation of this weak acid with a strong base is, what if they give you a solution of the weak acid, and then a solution of the strong base? Instead of a solid, they give you a solution of the strong base. The premise is still very much the same. You're taking some of this HF and you're using this KOH to convert it. So we have to start out. We have to go through and look at how many moles do we have of each and how you convert that. And there we go. So let's do this. So if we start off with how many moles of HF we have, that's 0.100 liters times 0.30 moles of HF per 1 liter. That means we have 0.030 moles of HF. That's what we have. We're going to convert some of that into F minus. So we're going to lose some of these moles, the 0.03 moles, to F minus. How many moles are we going to move over? How many are we going to convert? Well, let's figure out what the tool we're going to use is the KOH. And it turns out we have 0.100 liters and 0.15 moles of KOH. We're going to use that hydroxide per liter. And so that means we have, what, 0.015 moles of the KOH. That KOH is going to strip off that H plus to make some F minus. So if you have 0.030 moles of HF and you're going to strip off how much? 0.015 moles of H plus, what are you left with? You're left with 0.015 moles of HF remaining. And would you convert? Well, 0.015 moles of now your newly formed F minus. Why? Because this OH minus, this hydroxide, came in and stripped off that H plus to leave you with F minus. This 0.015 moles of KOH, this 0.015 moles of hydroxide came in and stripped off this many H pluses, leaving you with 0.015 moles of HF remaining, and your newly created, newly stripped off H plus, so right, the H plus is newly stripped from it, right, 0.015 moles of F minus. Okay, well, that's moles. It's good. It's not molarity. Let's take a look at how we get molarity from moles. Well, I need to divide that by the new volume. The new volume, in this case, we mixed two solutions, so the new volume is 200 milliliters, or 0.200 liters. So what are my new actual concentrations that I'm going to plug into my ice table? 0.075 molar HF, and also in this case, 0.075 molar F minus. Well, that's nice. They're not always exactly 50-50 mixes, but occasionally they are. This one worked out nicely. So, to review really quickly, again, we're using the KOH to strip off some H pluses from that hydrofluoric acid. In order to do that, we need everything in moles, so we know how much to convert. So we have 0.1 liters of 0.3 molar, so we have 0.03 moles, 0.1 liters of 0.15 molar of the hydroxide. So that's how much we're going to convert over. We're going to use that to convert that HF. That HF, 0.015 moles of it becomes F minus, leaving you with 0.015 moles of HF. Divide that by the new volume, 0.075 molar HF, and again, in this case, 0.075 molar F minus. Those two values get plugged into your initial concentrations in your ice table.